Hello again, everybody. Welcome back. This will be the last video. We're skipping way ahead to section 7.5. You really won't be responsible for this. It won't be homework or a quiz. There will be 2 questions on the final. You can choose not to do them, however. We'll talk about the final in the next video. So this is the last content video. By the way, this is the last day of the semester, Monday the 7th. So this is called solving trig equations. I could not let you go to calculus without just at least a little discussion about solving trig equations. And so here's the how-to. This is very procedural right now. You treat the trig function as a variable. And so, for example, I have over here, this is solve this equation. Treat the trig function as a variable. That's what we're isolating. Well, we're just doing algebra. But instead of an x, 2x minus 1 equals 0, this is 2 sine theta. And then so you isolate that variable, just like in, just like in algebra. Sine theta is a half. Notice the sign is IGN, the sign of that 1/2, because we're going to get to that in number 4. So now we have this. Now you use the inverse function. Well, on a calculator, for this, in this case, it would be sine negative with the -1. Inverse function on a calculator. More often than not, though, you can use the circular. Page 468, that's what I did for 3 out of the 4 examples we're going to do today. I used page 468. So now you have it. It's 30 degrees, however, because of, let's see, all scholars take calculus. Sine is positive, not in the first, but in the second quadrant. And notice the domain. We're going to talk about that as well as we go along with the examples. So I have to put it in the first quadrant, 30 degrees, and in the second quadrant, because it's positive. 180 minus 30 is 150 degrees. 30 degrees, 150 degrees, satisfies that equation. If you put those in for theta, you would get a true equation. So that's the basics of solving for solving a trig equation. Let me erase this board over here, and I'll do another example with cosine, and we'll put it in the domain in radians. Solve. Oh boy. Yeah, I gotta look it up. 2 cosine theta minus 3 2 cosine theta minus 3 equals -4. Solve that. Solve that and we give you a specific domain, and more often than not, it's going to be, whoops, 2 pi. Right. Solve it in all 4 quadrants. And so instead of getting theta in degrees, we're going to want it in radians. So now, here's the variable. We're going to isolate that, add 3. Divide by 2, -1/2. All I did is algebra. So now cosine theta is -1/2. Here's my advice. I know right now from this equation that we are in quadrant number 2 and number 3. I know right now. So instead of putting the -1/2 in the calculator, I would use a half, and then I would put the answer into the correct quadrants. My point is, the reference angle for theta is actually pi over 3. 60 degrees. If you had it in degrees, you'd get 60 degrees. That's the reference angle. That's the first degree. We want to put it in quadrant 2 and quadrant 3. Let me try to go over here, I guess. Quadrant 2 is pi minus pi over 3, which is 2 pi over 3. That's one angle. By the way, it's 120 degrees. And in quadrant 3, it's pi plus pi over 3, which is 4 pi over 3. And so those are the two solutions to this equation in this domain. Please note, from this equation right here, that's when you have to decide the quadrant. I think 2 more examples should do it. because they become quadratic in form. We're just going to do algebra, but let's just introduce you to ones that are quadratic in form. 2 sine squared minus 1 equals 0. 2 sine theta squared. So it's like 2x squared minus 1 equals 0. So you're going to solve for that equation. And so add and divide. Sine squared theta equals 1/2, positive a half. And then I'm taking the square root. Plus and minus. Puts it in all 4 quadrants right there, by the way. Square root of a half, which is plus and minus square root of 2 over 2. And by the way, every single time when I came to figure out the reference angle, I've used page 468. I have yet to press buttons. And next time I promise I'll be pressing buttons. But here, sine theta the square root of 2 over 2 is 45. Oh, it's 40. I didn't give you the domain. We'll do it in degrees. 45 degrees. And it's in all 4 quadrants because it's plus and it's minus. So it's 45. And what is it? Oh boy. 180 minus 45 is 130. 115. I forget. 250. So 45 degrees. 315. 180 plus 45. 225. 180 minus 45. 130. Okay, there we go. Those are in degrees. By the way, for me, this is easier in pi in radians. Those are degrees. 45 degrees is pi over 4. 2 pi over 4 is 90. So this is 3 pi over 4. 4 pi over 5. Pi over 4. 7 pi over 4. And these 4 are solutions to that equation. All right. Cruising right along. Let's do one, let's do one that I have to press the buttons. And by the way, I'm going to use tangent this time. Only because we haven't done tangent yet. And so, but with tangent, as an instructor, you can make up anything. Because tangent, the whole domain for, the whole range for tangent is all the reals. So I haven't done it. 5 tangent theta minus 7 equals 8. 5 tangent theta minus 7 equals 8. I have it in degree. I have it in both. Let's put it in degrees, I guess. First, in calculus, please get used to radians and get used to pressing buttons with radians. But here we go. So now here's the variable. I'm going to isolate it. Tan theta equals what? 15 over 5, 3. Right now, I know it's in the first and third quadrant. Quadrant 1 and 3. Because tangent theta is positive. Okay, now is when I have to press buttons, right? Okay, I have it in degrees, I believe. No, I haven't. Now it's in degrees. I have to put 3 in first, and then inverse tangent. 71.56 degrees. That's a reference angle. Let's call it 71.6 degrees. That's what it is in the first quadrant. And then it goes in the third quadrant as well because all scholars take calculus. So I'm adding 180 to this. 251.6 degrees. Real quick, in case it was radians. Whoops, radians. There we go. 3 inverse tan. 1.25 radians. That's in the first quadrant. Pi over 2. And then in the third quadrant, I would take pi plus 1.25 radians. That's good enough. Or you could actually add them. 3, 1, 4. That would be a 9, 3, 4.39 radians. In the third quadrant. You could check that out yourself if you want. So, here we go. I just want to make sure the list, 2 solves. Trig, sine theta, cosine theta, tangent theta. We're not going to talk about what the other 3 trig functions are. You just have to use your simple. Trig function. as a variable. And then the rest is algebra, too. Solve, isolate the variable and solve. And you solve using either a calculator or page 468. Page 468. I keep calling it that. It's the circle. You should have it. And by the way, this is inverse trig function. Sine, cosine with a -1, or tangent with a -1. You have to press an extra button. Decide quadrants. And then use the reference angle to solve, to decide the quadrants and solve it. Use reference angle, I guess. For solutions. And it may be more than one of them, of course. Okay, I hope that's helpful. Again, I'm not sure. I hope that's helpful. See you next time.